The triangle sum theorem is one of the main theorems you're going to see in geometry. And this one says the sum of the measures of the interior angles of a triangle is 180 degrees. Now, not only are you going to solve a whole bunch of problems where you're looking at finding the angles of triangles, it gets embedded in other problems, but it even goes beyond that. When we look beyond triangles and look at quadrilaterals, pentagons, hexagons, other polygons, it really comes back to this theorem. So what are we really doing here? So we have a triangle. And this could be any triangle. It doesn't say it's acute, obtuse, right, scalene, isosceles. It's just any triangle. So at any triangle, if we label it, we'll call it ABC. Those three angles will always add up to 180 degrees. You cannot create a triangle where the sum of the angles is not 180 degrees. And that's a nice rule to have because we know it's always going to work. So what we're saying here is that the measure of angle A plus the measure of angle B plus the measure of angle C equals 180 degrees. Now, before you go on and start solving problems with it, where does it come from? We're not just making up this 180 degrees number. There's actually a basic proof we can look at to see how it works. So what we're going to do is we're going to create a triangle. I'm still going to label A, B, and C. And with this, I'm going to first now draw a parallel line, a line that's parallel to AC that goes through B. And we can do that because that's the parallel postulate. And the parallel postulate says there exists exactly one line through a point that's parallel to any line. So there exists a line that goes through B that's parallel to AC. We can do a little better than that. There we go. So there's our line parallel to it. And I'm going to put a couple points on there. And we can even add some points on there because that's one of our basic postulates that we have, that we can have multiple points on a line. We're going to go D and E, just to make it a little bit easier to reference. So we have angles A, B, and C, and we know they add up to 180. For the sake of this proof, though, let's label the angles with numbers. We have 1, 2, and 3. So I know that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180. Now, what can we also find here? Now, we said we had parallel lines. If I labeled angle 4 here, not only is angle 4 could be called DBA, and it does hit that parallel line, but it's actually congruent to angle 1. And the reason that angle 4 is congruent or equal to angle 1 is they're what we call alternate interior angles. And alternate interior angles, when you have parallel lines, are congruent. Okay, well, let's see. Well, that worked for 4. Well, we'll call this one 5. 3 and 5 are the same thing. Angle 3 is equal to angle 5. And the same reason, alternate interior angles. So what does that do for us? We need to say that, we'll show that 1, 2, and 3 add up to 180. We can't just, that's what we need to get to. This is our goal here, even though we wrote it first. This is the goal we want to show. But what we can say is that the measure of angle 4 plus the measure of angle 2 plus the measure of angle 5 adds up to 180 because, first of all, that total of all of those angles is a straight angle. It's a straight line, so it's 180 degrees. And we can add angles together by the angle addition postulate. So all we've done here now is we can take the 4 and replace it with something that it's equal to, angle 1. We can take the 2, which stays the same. It's in both of them, really. It's in the straight angle, and it's in the triangle. And we take 5 and replace it with angle 3. And we still have that 180 degrees. Now, what lets us replace them? It's something we call substitution.